Hello everyone, I hope you all are having an amazing day. So in this project, we will actually work on the Fandango. So Fandango is actually a movie critics or online review and rating type of website, just like IMDb or Rotten Tomatoes. But additional to reviewing movies, Fandango also sells movie ticket. So is there any bias towards rating movies higher than they should be rated biased way? Okay, and our goal is to find out, is there any biasness compared to other movie review type of websites or not? Okay, and there is actually an article, and I have actually linked it here, so you can click this link and read the article to know about more behind the Fandango's scandal. Okay, and we actually have two CSV datas. One CSV data that is called all sites score, so it has the different film names and different website score, like Rotten Tomatoes score. And Rotten Tomato actually has two type of score. One is the Rotten Tomatoes the officials score, and another one is the Rotten Tomato users score. Okay, and these are in percentages. Similarly, Metacritic also has two scores. One is Metacritic officials score, and another one is Metacritic users score. Similarly, we have IMDb raters scores. And then we also have like Metacritic's voting count, and then IMDb users voting count. Okay, and for Fandango, what we have is that Fandango, we have the movie name, we have the actual rating, we have the number of people voted the rating, and the star that is actually presented by Fandango. So the thing happening is that the users actually put the rating for a movie. So the rating could be it's between 1 to 5, and the rating could be 3.9, 3.8, 4.66, something like that. But what Fandango does, they actually shows the stars. Okay, they does not show the rating. So what they do, suppose you gave the rating as a 4.33. So what Fandango will do, Fandango will show a star like 5 star. Okay, because 4.5 star does not it is actually impossible. So they actually show 5 stars instead of the real ratings, and because of that, they are actually creating biasness to actually push the sales of any specific movie. And with this data analysis, with this exploratory data analysis, we will try to figure out their biasness, and we'll try to expose Fandango. So for that, what we did, we actually imported some Python, our regular Python libraries. So we imported NumPy, Pandas, and all other things. Now we are actually importing the data sets. Okay, at first we are reading the Fandango script, the CSV file in our Fandango variable, and let's check the data. So you see the data has 4 columns. Film has the name of the films, star has the stars, and then ratings, and then the votes. So votes mean the number of people rated um, rated the movie, and this is actually the average rating from this number of people. And then in the info, we can actually see the infos, like how many columns are there, how many rows are there, if there is any null values, so that data is actually clean data, so you don't have to perform data cleaning. Okay, now let's check the summary statistics of the Fandango. So we can see, okay, let's use transpose. So we can see that the average stars is around 3.5 stars. Average ratings is around 3.37, and average vote for each movie is around 1148. Okay, so you see there is a very visual discrepancy in the average scores between ratings and star. We can see that the average score for a movie in Fandango is around 3.37, but the star it increased to 3.55. This should not happen, but this is what happening because of their methodology. So yeah, we will actually try to expose Fandango slowly. So let's move on. So now what we will do, we will actually try to create to see if there is any relationship between the rating, movie rating, and then the number of people actually voted that specific rating. So what we will do, we will actually use the C1 package and the scatter plot function. So this is the movie rating we can see, and from the rating we can see that it's actually kind of fine. People actually what is it called? People actually voted nicely. Okay, there is actually cannot we actually cannot see anything fishy here. Um, and another thing is that we can see that the more the rating, the more the voting of the people. Okay. Now let's check the correlation. So we can check the correlation bit among the numeric columns by selecting the numeric columns like this and using the dot C or double R function. So what is actually correlation? So correlation is that a measure that shows the relationship between two variables. So here we have the relationship between stars and rating, and the relationship is 0.99. Okay, and there is a relationship between stars and votes. The score is around 0.1642, so that is very low between these two scores, between stars and votes. The correlation score is very low. Similarly, we have another one that is the rating, the correlation or the relationship between rating and votes, that is 0.163. That is also very low. Okay, that is also very low. Okay, so this kind of the relationship, the relationship measures or the correlation values we can actually find by implementing this implementing this function. So this is called correlation analysis. And now what we will do, we will actually um, try to get the year from specific movies, because we want to see how many movies actually released for each year, okay, in our data. So let me just show you how are the film names actually uh, in our data. So you see that the film names are actually like the name of the film, and then that year, and then the release year is actually inside the bracket. So what we can do, we can actually create a lambda function that will take each film name, and then at first it will split the name or the specific movie name based on the bracket. And then what we will do, we will actually replace the bracket, and we will actually take out the year value. Okay, so let me show you how to do it step by step. So let me just copy this fully and paste it here. So when I apply this, so you see that I'm only finding the year values. But what is actually happening here? So using the lambda function, we are actually taking each movie title, and then at first we are actually splitting the movie title based on the first bracket, based on this bracket. So what will happen if we do this? So it will create a list in each rows or in each film names. It will create a list in each film names, and this is the first object of the list, and this is the second of the object of the list. Now what we can do, we actually need the second object, that is 2015, and with also the second bracket or the ending bracket. Okay, this is whole the second thing. So and we can actually only read in the this second value by using third bracket and -1. Okay, now let's run this. So now you see we are only reading the 2015 and bracket. Now what we can do, we can actually use the replace method to replace the ending bracket as nothing. So here we are using the replace method to replace the ending bracket with nothing. Now if we run this, so we are getting only the year values. So this is how um, we are separating the release years from our movie name. And we will set the column name as year, or create a new column with our data set that is called year. Okay, so now if we just use the value counts, then we can see the number of movies per each year. Okay, so there are 2015, there are 478 movies. In 2014, there are 23 movies in our Fandango data frame. And we can also visualize it using count plot. So here it is. And now what we will do, we will try to sort the name of the movies based on number of votes. Okay, with highest number of votes. So you see, I used had a 10, so it will actually show me the top 10 movies. And here using sort values, and inside sort values I have used the votes, so it will show me the highest votes. It will show me highest votes because I actually put false inside ascending. So we say that 50 Shades of Grey has the most votes, and then Jurassic World, and then American Snipers, and so on. So now you see that the movie rating is actually 3.9, but they are giving the movie the stars, showing the stars as 4. Similarly, you see the movie rating is actually 4.2. Okay, it's actually 4.2, but they are actually showing it as a 4.5 star movies. Okay, so this is clearly a biasness. Okay, this is clearly a biasness. And here, see, the rating, average rating is a 4.5, but what are they doing? They're actually showing that movie as a 5-star movies. So this kind of biasness we will actually solve, and we will actually expose Fandango in the upcoming analysis. Now what we will do, we will try to find out if there is any a zero vote movies. So we see that there are actually 69 movies and that has not been voted by any person. And what we will do, we will just use the conditional filtering and just remove all those movies that has 0 votes. Okay, so now this fan reviewed data frame, it only contained the movies that are actually voted by people. And now what we will do, in order to understand the distribution of ratings versus the stars showed, we'll actually create a frequency distribution plot, okay, or KDE plot. So here in the KDE plot, just try to understand two things. So the ratings, so this is in, in the blue shade, the rating. So, and the rating is the original rating given by each viewers. Okay, and the star showed are the Fandangos showing the stars. Okay, and here see the actual rating for the 5 is very low. The density is very low for the actual rating, that is 5. But you see what Fandango is doing. Even though the actual rating for 5 is very low, the Fandango's 5-star rating is actually very high. The density is very much up. Okay, very much high. So there is, of course, Fandango's doing something fishy in order to, like their data is actually not supporting this thing. They're actually manipulating their data to we will actually quantify this discrepancy, yeah, these differences. And what we will do, we will create a new column, and it will actually be the difference between the actual rating. It will be like the stars they are giving minus the actual rating. Okay, so here we created a new column that's called stars diff. So you see these are the differences. Okay, now we will try to plot the differences. So you see there is around, okay, let's use fan reviewed comma stars div dot value counts. Okay, great. So you see around 107 movies are actually correctly shown. The stars are actually correctly shown for only 107 movies. Okay, but you see they actually showed more stars for 82 movies, 0.2 stars for 82 movies, 0.3 stars for 72 movies, around half stars for 70 movies, 0 0.1 stars for 66 movies, 0.5 stars for 37 movies, and one movie. And for one movie, what they do, they showed a completely 1 star more than is actually rated. Okay, there is one movie that is actually rated 4, but they are, I think they are showing it as a 5 star. Okay, and the difference is 4 and 1, that is 1 star difference. Okay, and we will actually find out what movie is that. And we are actually showing the same information here by visualizing it in bar chart or column chart. And here the main thing is that we can see from the plot that one movie was displaying over 1 star difference than its true rating. What movie had this close to 1 star differential? So let's find out using conditional filtering. So we see that there is a movie called Turbo Kid. Its original rating is 4. Two people voted it, but they are actually showing it as a 5 star movie. Okay, and this is completely biased, and this is actually very uh, not ethical. Okay, this is actually not ethical. Now what we will do, we will try to see like the movies we have in our Fandango data frame. We will try to see how the other movie reviewing sites are actually reviewing those movies, and we will compare the scores. Let's now compare the scores from Fandango to other movie sites and see how they compare. Okay. So now we will read our data and let's see what kind of data we have. So we have movie names with their release years, the Rotten Tomatoes score in 100%, and Rotten Tomato users score in 100%, Metacritic score, and Metacritic user score. So you see the Metacritic score is actually like is on 100 scale, but the user's score is on 10 scale. Similarly, IMDb scores is in 10 scale, and the number of voters for Metacritic you see the 1330. So 1330 or 1330 voters voted 7.1 for Avengers Age of Ultron movie. Similarly, in IMDb, around 271,000 people voted 7.8 for Avengers Age of Ultron. So IMDb does not have any officials rating. IMDb is actually fully uh, like the user based ratings. Like the user based, I mean those who watched a movie, they actually rated I in the they actually only they can rate the movies. There is no officials are related. So by officials, I mean the employees inside or the specialist movie critics. This kind of stuff are not available inside IMDb. So IMDb only has users rating. Similarly, we can see the info if there is any null values in our all sites info data. And similarly, we can see the summary statistics. Okay, very good. So for the summary statistics, you see that there is very less discrepancy between Rotten Tomatoes users score and Rotten Tomatoes actual score. Okay, actual score, you mean the official score, that is around 61, and the user score is around 64. So not much difference. Similarly, Metacritic, IMDb. Okay, so everything is looking quite okay. Now let's start with Rotten Tomatoes. If there is any relationship between Rotten Tomatoes critic reviews and Rotten Tomatoes user reviews. So you see that it's actually very nicely distributed. Both the Rotten Tomato critic reviews and here we have the Rotten Tomatoes user reviews, and you see that that both are increasing. When the Rotten Tomatoes critics score increase, the Rotten Tomatoes users are also scoring similarly. So there is actually a uniform distribution or uniformity here. Okay. But let's try to find out the differences. So what we will do, we will create a new column that is called Rotten diff, and that will be the critics score minus the users score. Okay, now let's try to see the mean absolute difference of the rotten diff column. So the average difference score is around 16. So that is actually fairly high, but as we are actually considering the absolute, so this means we're actually not considering those minus values. So maybe that is why the values got a bit higher. But 15 on average, the difference is quite high. But let's see. So now what we will do, yeah, we will actually plot the distribution to see what is actually going on. So we can see that the difference is we actually plotted the distribution for the difference, and it is actually showing a bit left skewed, but we can see it's approximately normally distributed. Okay, now we will try to see the absolute difference between critics score and users score. Yeah, so this was like it was not absolute, it was like the original. Okay, and this one is the mean absolute scores distribution, and it's actually very much right skewed. Okay, now let's find out what is causing this huge difference. Okay, what is causing this huge difference? And let's see from the like lowest five lowest reviewed movie if in Rotten Tomatoes. So you see that users love those movie but critics hate. Okay, so how is that? So there are five such movies. So in those movies we actually have like minus rotten scores. So what does the minus rotten score means? So please try to remember that the rotten diff is actually the critics score minus the users score. If critic scores a movie 50 but the users score a movie 80, then there the difference will go to the minus portion. Okay, there will be a minus 30 difference. So this means if the difference score is minus 30 or minus, this means that that specific movie users loved the movie but the critics did not love the movie. So based on that condition or based on that logic, we can find out the top five movies that are actually loved by the users but hated by the critics. So these are the movies. Similarly, let's see the opposite thing. What are the top five movies that critics actually loved but users did not like so much? So there are five such movies. We can see that the rotten difference is positively higher. Okay, so users did not like those movies, but the critics actually did love this movie. Similarly, what we will do similar analysis for Metacritic also. So the distribution for Metacritic score is also, you can see, you can say uniform or symmetric. Let's do it for IMDb. Okay, so here we are actually trying to see if there is any relationship with the IMDb user vote count and Metacritic user vote count. So there is actually a fairly relationship, because when the Metacritic users vote count is much, there is also IMDb voter counts. Okay, so there is actually a fairly relationship between both these two variables. Okay, but we can actually see some outliers here. Suppose this outlier. Notice there are two outliers. The movie with the highest vote count on IMDb only has about 500 Metacritic ratings. What is this movie? So you see that, yeah, this movie. So for the IMDb, this movie rating has like a lot of people actually voted this movie, but in the Metacritic, uh, it actually have around more than 500 Metacritic voters for this movie. So what is actually that movie? So by actually plotting this scatter plot, we can actually find out if there is the discrepancy between the number of voters for a specific movie. Okay, just like this. So yeah, let's find out. So the highest IMDb voter count, that is around 334,000. So this movie is The Imitation Game, but around 566 Metacritic users voted this movie. Similarly, let's see what movie is actually the highest for Metacritic. So you see that the Metacritic, the highest movie R is 2,375 persons voted. That is Mad Max Fury Road. Okay, so this is the highest rated movies from Metacritic. Now let's compare the Fandango with all other sites together. So for that, what we will do, we will actually do inner join based on the film names, okay, with Fandango and then our another data that is called all site. So we will use the merge function from the pandas library, and we will do the join using inner function. Okay. Now let's check. Now we have around 145 movies that actually matched between both the datasets in Fandango and also in all sides table. So here's the sneak peek. All the columns are actually here. Now let's try to normalize the ratings. So normalize the ratings and in in 1 to 5 rating, because for our Fandango you see the ratings are actually between 1 to 5, but the Rotten Tomatoes there are ratings are actually in 100 scale. So we'll have to normalize those things, those scales. So to normalize, what we'll do, we will just just divide the scores for by a specific number. So for Rotten Tomatoes, to get it from 100 scale to 5 number scale, we'll actually have to divide the scores with 20. So, and we are actually calling those columns as Rotten Tomatoes norm and Rotten Tomatoes user norm. Similarly, for Metacritic critics score, we will have to divide the main score by 20. But for users score, we are actually dividing it by 2 because the users score was actually on 10 scale. Similarly, IMDb rating was also in 10 scale, and we are just dividing it by 2 to convert it to 5 scale score. And let's check the data again. So if we scroll on the right, and we can see our normalized score. So all the movie sites score are in 5 scale score now. Now we will create a separate data frame only taking the scores. So what we did, we actually created a new data frame by subsetting, or by only taking the stars from Fandango, rating from Fandango, and Rotten Tomatoes rating, Rotten Tomatoes user rating, Metacritic's rating, Metacritic's user rating, and IMDb's rating. Now we will actually plot. Now we will actually plot all those ratings in a distribution plot, in a KDE plot. But before that, what we created here, we actually created here a what is it called? A function that actually moves the legend according to our um, what is it called, our direction. Okay, and you can find the details behind this legend in this link. Just click on this link and you can understand what I have actually done. So you see that the stars is actually this thing. This is actually the stars. Okay. So this is actually the stars or the fake rating by Fandango, and the blue thing, the rating. So this is actually the original rating from Fandango. And we also have the all others, the Rotten Tomatoes and everything. So just notice like the Rotten Tomato critic scores, it's very uniformly distributed. It's very uniformly distributed. But notice the stars. It's actually not very uniformly distributed. Okay. Similarly, notice the ratings that is actually coming from the same Fandango website. You see, so for the rating 5, just notice where the actual rating ended. So the actual rating density is here, that is around 0, that is actually less than 0.02. But the fake rating or the stars from the Fandango, it's actually much more than the actual ratings. Okay. And also compared to um, just okay, just the Rotten Tomatoes is actually higher than the fake ratings, but consider all other ratings like IMDb or Rating Tomatoes user reviews or Metacritic user reviews. All other ratings are actually less than the fake star reviews. Okay. So here, clearly, Fandango has an uneven distribution. We can also see that RT, Rotten Tomato critics, have the most uniform distribution. Yeah, as I actually said a while ago. Let's directly compare these two. Okay, let's compare only Rotten Tomatoes and the fake reviews from Fandango. So we are actually using subplots to do the things. So here you see the red thing is actually our Rotten Tomatoes critics score, and it is actually very uniformly distributed. But see the fake reviews, yeah, it's actually a lot, yeah. So whereas the Rotten Tomatoes has density less than 0.1, the Fandango stars have density above 0.35. Okay, so there is clearly a discrepancy. Okay, now similarly, what we can do, like, so we actually created a distribution plot here to understand it better, but we can do the similar thing by creating a histogram here. Okay, this is actually same thing more or less. Okay, how are the worst movies rated across all platforms? So yeah, let's now check a heat map, or we say it actually cluster map, and that find out how actually Fandango rating their movies. So you see that these stars, okay, and this rating is actually for Fandango, and these are other movies, okay. And just see the colors here. So the lighter colors means higher rating, and the darker color means like lower rating. Just compare with the stars, like the colors here with colors from the others. You see these, so there are a couple of movies here, okay. There are a couple of movies here, and they are actually very harshly rated by Rotten Tomatoes critic. But see, for Fandango, those movies are actually fairly rated, okay. And not only compared to Rotten Tomatoes, you can see for Rotten Tomato users, Metacritic critics, and Metacritic users, and also IMDb users, those same movies are actually very harshly rated. But in Fandango, they are actually fairly rated. So there is, of course, something fishy going on in the Fandango uh, movie website. Clearly, Fandango is rating movies much higher than other sites, especially considering that it is then displayed a rounded up version of the rating. Let's examine the top 10 worst movies Based of the Rotten Tomatoes critic ratings, what are the top 10 lowest rated movies? What are the normalized scores across all platforms for these movies? You may need to add the film column back into your data frame of normalized scores to see the result. Okay, now let's create another data frame, only taking out the five scale scores and the film. And now, based on Rotten Tomatoes critic scores, let's see the worst 10 movies. Okay, so so you see the Paul Blurt's The Mall Cop 2. So this is actually rated the lowest by Rotten Tomatoes critic. But you see, for Fandango, it's actually rated as 3.5 star movies. Not only by, but compare it to not only Rotten Tomatoes, compare it with other sites also. Like for Meta, no, like for the Metacritic, the critics score is 0.6, very low. The users score is 1.2, that's also very low. IMDb score is around 2.2, that is also very low. So 2.2, 1.2, 0.6, 1.8, 0.2 versus 3.5. So this is actually very much fishy score, and this is actually not good. Similarly, we can see the same thing going on for the other films as well. Now, the final task is to visualize the distribution for those 10 movies. So let's see. So what we are doing here, we are actually only taking these top 10 movies by using norm films and smallest, and we're dropping the film column because film column is actually a text column or a string column, and text column or string column will not help us to generate this KDE plot. So we are actually dropping the film column. And then what we are doing inside our KDE plot, we're actually putting the worst films in the whole data frame, and then we are clipping it. For clipping it means we want to see for only 0 to 5, and fill is true because so that we can see the colors, and we are using palette that is set one and the title. Okay, so here you see the distribution. Okay, see almost. So the blue and this red is actually coming from Fandango. But if you ignore this blue and red, see all other platforms score is actually ranging from 0 to 3.5. But only for the Fandango, the scores are actually ranging from 2 to 5. Okay, so there is actually easy visible discrepancy in the rating scores. Okay, so let's do a manual checking. Like for so here, so these are actually the number of rows. Okay, the index numbers. Okay, and you can see that there is a movie in index 130. Okay, and it's rated very bad. It's rated very bad for all other movie sites, but I think it's rated around 4.5 stars for Fandango. So let's find out this movie. Okay, so let's find out this movie. So I think um norm films dot 25 dot ilog 25, yeah, dot ilog 25, yeah. So you see that, oh sorry, not 25, 130. So you see that there is a movie called the dark places. Okay. And we can see easily that Rotten Tomatoes scores are very low. Metacritic scores are also very low. But for Fandango, the score is very high. But I think the worst rated movie was in the 25th, that is Taken. For Taken, you can see the Rotten Tomatoes scores are very low. Yeah. But and the rating is was actually around 4, but they are actually showing it as 4.5 stars movie. So, and if you take the average, okay, if you take the average, like all those numbers, so on average, the movie's score is around 1.86 compared to 4.5. So that is actually clearly a non-ethical thing happening um, in Fandango here. So